Okay, we already talked a little about this and we mentioned some vulnerabilities before, but right now let's dive a little deeper and explain which vulnerabilities exist and also give a demonstration of one in the next video and how to prevent it. So, in reality, battling against vulnerabilities is a battle on multiple fronts. Threat can come from anywhere and from anyone, and that's why there is a trust model in cybersecurity that is called zero trust. Essentially, it means to trust no one. Now, these vulnerabilities I decided to divide into two main categories. First one are software vulnerabilities, and of course this is a broad division, so we must divide it further down. Here are the most common software vulnerabilities. First one and most dangerous one is a zero-day vulnerability. We already mentioned it, and it is a vulnerability that has not been discovered yet and not patched. This type of a bug or a vulnerability is a constant threat to every organization that is on the internet. Another type that you will usually hear about are OWASP top 10 vulnerabilities. This is a set that developers should be introduced with and that should be applied for any web application security. If you're developing a web application, you should most likely be familiar with all of the top 10 OWASP vulnerabilities. These include injection type of vulnerabilities such as SQL injection, command injection, cross-site scripting attacks where JavaScript is injected into unsanitized user input. We also have broken access control attacks and many more. Usually, these vulnerabilities occur when user input is not well filtered, or they can also occur due to some type of misconfiguration in the application. Again, more about OWASP top 10 vulnerabilities you can check out inside ZTM Bug Bounty course. This leads us to another type of vulnerabilities which can occur from misconfigurations. This one is common since the larger the code that is used, the more chances that something is not configured right or implemented right. Remember, it's not one developer that writes entire code. Especially for bigger softwares, we have multiple developers, each of them has a assigned task, and they each devote to one specific task that they get. None of them really wonders too much about one thing being well configured with another thing, and that's where some type of misconfiguration can occur. And then this can lead to vulnerabilities which exploit these misconfigurations. They're also common in access control types of configurations. Perhaps you prevent employees from accessing a website configuration page, but you don't prevent them from accessing a different page which interacts with the website configuration page in a way that might allow the employee to change something. Again, this is broad division, as these types of vulnerabilities can occur really anywhere. Another danger comes from outdated software. Imagine a zero-day vulnerability comes out and everyone patches their systems to prevent it except you. You no longer are vulnerable to the zero-day vulnerability but to the outdated software vulnerability, since the patch is already out. That's why it's always important to patch every code and library that you have or that you have used whenever a bug is found. And last but not least, we have man-in-the-middle and DDoS attacks. Man-in-the-middle attacks can be prevented by certain network security measures, which we will talk about in the network security section of the course, but what man-in-the-middle essentially allows you to do is sniff others' traffic on the network. While years ago this was common and possible in almost every network, nowadays more and more security implementations against this are being done. Same goes with DDoS attacks. More and more denial of service attacks are being prevented with different security measures. Now, one thing I want to point out to anyone wondering where these attacks mostly come from, if I had to give you one advice, I would say always check the code where user input can be provided. This is the number one spot where these type of software vulnerabilities occur. Now, these do not include man-in-the-middle attack and denial of service attack, but all the others that we mentioned mostly occur due to invalid user input. Whenever a user input is provided in a place where that user can manipulate the code and make it do something that it isn't supposed to do, Just remember, this is the number one spot where vulnerabilities occur. Whenever a user input is provided in a place where the user can manipulate the code and make it do something that it isn't supposed to be doing, that's a place where a vulnerability can occur. So just remember to always filter user input so that it only accepts exactly what you want it to accept, and we will actually see why this is important in the next section. Okay, but these are actually lesser common vulnerabilities that get exploited out in the open. The more common set of vulnerabilities is something I like to call human vulnerabilities. This is number one problem on the internet, since most people aren't educated enough to know what they should and shouldn't do on the internet. These human vulnerabilities include social engineering or phishing attacks, downloading unwanted software, opening unverified emails, which essentially means opening emails that appear to be coming from the trusted source, but in reality, they are not to be trusted at all. And another one is clicking on random links. All these can result into not only the employee of the company being compromised, but the entire company as well. This is where that zero trust model comes in play. Before, since the employee was behind a firewall and all the security measures of the company, and was a trusted node in the company's network, it was easier to exploit the entire network after actually getting access to that employee's machine after, for example, running a social engineering attack. But with zero trust, none is to be trusted and you expect a threat to come from anywhere. Anyways, now that we know what vulnerabilities are we dealing with, let's take a look at an example of how attackers actually exploit one of these vulnerabilities when they see it.